Hey everyone, in today's video we're going to be solving the problem binary search trees. The question says given an array of integers n representing in-order traversal of elements in a binary tree, return true of the given in-order traversal can be of a valid binary search tree. Note all the keys in a BST must be unique. Okay. So the question says that you're given an array of the in-order traversal of a binary tree. Okay. And as you might know, the in-order traversal of a binary tree is L and R, which means you go to the left node first, then the node of the tree, then you go to the right of the node. Right. So this is what the in-order traversal is. And the question says is that you need to return true if that in-order traversal array can become a valid binary search tree. Now, for those of you who don't know, if you do an in-order traversal on a binary search tree, what you'll get is a list of nodes in a sorted form. So, if you just think about it logically, if you have a binary search tree, right? In a binary search tree, all the nodes that are on the left are smaller than all the nodes that are on the right. Correct. So if that's the case, if we go and when if we traverse it in an LNR fashion, in an in-order traversal, you go to the leftmost node first, then you go to the node of the tree, then you go to the rightmost node, then you go to the right node of that leftmost node. Okay. If you go in that form, right, then you probably will just go in forming an array of nodes which are in a sorted form. Right. So this is what basically binary search trees are. So if you traverse the binary search tree in order traversal, you'll get a list of nodes in a sorted form, which is basically a sorted array of your outputs. Right. So you'll get your array in the smallest to the greatest node. So this is what this means. And if your tree over here your binary tree is given in the form of uh, in the form of an in-order traversal. What you just need to do is you just need to check if every node we're traversing, like if we start from this node, if is this node smaller than this node, then the very next node ahead of it, and with and simultaneously, and just we just need to keep on checking for every node like that, whether 14 is less than 45, whether 45 is less than 64, whether 64 is less than 100. Just need to keep on checking like that. And if any point, if it's not true, you just return a false, and if it is true, if all of them are true, then you just need to return true as our output. So let's just solve the problem here. So it's going to be length of nums nums length of nums minus 1, because we're going to be checking for I plus 1. I plus 1 is greater than nums of I. Then continue. Else we'll just return false. And if all of them are true, then we'll just return true. Okay, so let's just run the code. So yeah, it's coming true. Let's submit it. So yeah, guys, it's submitted. So yeah, guys, that's all for today's video. If you like the video, do like, share, and subscribe, and do check out my podcast and do write down in the comments what kind of videos you want next on the channel, and also let me know if you'd want me, any kind of better explanation for any videos. And until next time, guys, thanks for watching.